We covered binomial expansion in year 1, so make sure you understand everything in that chapter. Go back to the video I made if you need to. In that video, we saw that you could expand brackets of the form a plus b to the power of n, where n was a positive integer. So for example, you could do 3x minus 2 to the power of 6, x minus 3 to the power of 4, 1 plus x to the power of 5. We learned how to expand brackets like these. But what if n, this number here, what if this isn't a positive integer? What if it's a fraction? What if it's negative? Or what if it's even a negative fraction? This video is all about that. Let's start with 1 plus x to the power of n, where n can be any number. So there is a formula for expanding any bracket of this general form, and it's this formula here. Now, this is a really long and complicated formula, and it's given to you in the formula booklet, so you don't need to remember it off by heart. The main takeaways is that it goes up in powers of x. So it starts here with no x in the term, then it's x to the power of 1, then it's x to the power of 2, then it's x to the power of 3, and then so on and so forth like that. And then from x, it starts with the coefficient being multiplied by n, then the coefficient is multiplied by n times n minus 1, then it's n times n minus 1 times n minus 2, and then it goes on and on like this. And each coefficient has this increasing factorial that is divided by here. It starts by being divided by 1 factorial, but as this is just equal to 1, we don't rewrite it. Then it's 2 factorial, and then it's 3 factorial like this. If you don't know what a factorial is with this explanation mark here, it basically means that it's this number here, but it's multiplied by all the positive integers before it. So for example, 5 factorial is equal to 5 times 4 times 3 times 2 times 1, like this. And we can see that this formula is long and complicated, and therefore it's only useful when we cannot use the technique from year 1. So when n here is either a fraction or a negative number. You can technically put positive integers of n into this formula, but it's a lot easier just to use the year 1 technique for that. So here's an example question, and the first step of this is realising that this here is of the form 1 plus x to the power of n, because we can write this, remember how indices laws works, as 1 plus x to the power of a half like this. And as n is equal to a half, a fraction, we need to use this formula here. Now I've kept this formula here and will do for this whole video because you will have it in the exams. It's in the formula booklet. Now one thing to note with this question is it says go expand it up to including the x to the power of 3 term. And the reason for this is this formula goes on forever. It has x to the power of 4, x to the power of 5, x to the power of 6 terms, etc. So they will have to give you a certain amount of terms to go up to. So let's do this. So the way that I did it in year 1, the same way that I'm going to do it, and I'm going to lay it out here, is I'm going to do it term by term. So the first term is always just 1, and then the second term is nx, so it's going to be equal to a half x because n is equal to a half. And then the third term is going to be n, so a half, times n minus 1, so a half minus 1, over 2 factorial and then multiplied by x squared. We can simplify this to a half, and then a half minus 1 is minus a half, and this is over 2 factorial, is just going to be 2 times 1, so it's just going to be 2, then x squared, and then this is going to be equal to a half times minus a half is equal to minus a quarter over 2 x squared. And then if you figure this out by doing it by fractions, minus a quarter divided by 2 is equal to minus 1 over 8 x squared, like this. So this is the second term, and then the third term is going to be n, so it's going to be a half, then n minus 1, so a half minus 1, and then n minus 2, so a half minus 2, over 3 factorial times x cubed. Now I always try to use mental maths in these questions because I really think for practice questions it's good to use mental maths to practice like algebra, because with algebra you use mental maths. As this is quite long, I'm just going to put this into a calculator. 3 factorial is just equal to 6. If you put this into a calculator, this is equal to 1 over 16 x cubed, so like this. And it only wants us to go up to the x cubed term, but it wants us to include the x cubed term. So this is why I've done this. So therefore it's just going to be all of these terms added together. So it's going to be 1 plus, and then it's going to be a half x, and then it's going to be minus, it's going to be minus this term, so minus 1 over 8 x squared, and then plus 1 over 16 x cubed. So this is the expansion up to the x cubed term. Now, one very important thing, for this formula to work, the modulus of x has to be less than 1. Any values of x that we sub into this expression here, they only work if the modulus of x is less than 1. So, for example, let's say that x is equal to a half. So if we sub x is equal to a half into this here, it's going to be equal to 1 plus a half to the power of a half. And if you put this into your calculator, it gives out a value of 1.118 and then a bunch of numbers like that. If you sub x is equal to a half into this expression here, so you sub it into the values of x, if you put it into your calculator, it also gives out a value of 1.118 and then a bunch of numbers like this. They give out the same answer to 3 decimal places, so it works fine. If you went to more decimal places, you would see they don't give out the exact same answer. And this is because we've only used the first 3 terms here. We've only gone up to x to the power of 3. But a lot of the time, you only need the first few terms to get an extremely accurate approximation. To get the exact answer, you need to put all of the terms like this, and it will just go on forever. But if we say that x is equal to 7. So if we sub x is equal to 7 into this, it would be 1 plus 7 to the power of a half. And if you put this into a calculator, it gives out the value of 2.693 and then a bunch of numbers like this. If you put x is equal to 7 into this and you put it into your calculator, it gives out a value of 19.813 and then a bunch of numbers like this. We can see that there are 2 massively different numbers here and it doesn't work. This approximation here doesn't work. This value of x works, x is equal to a half, because the modulus of x is less than 1. But this value of x does not work because the modulus of x is not less than 1. 7 is bigger than 1, so therefore it doesn't abide by this, so therefore we cannot use this value of x and put it into this expansion here. So here's another example. This time we need to expand 1 over 1 plus x to the power of 2. So again, the first step is realizing that this is in this form here, because we can write this, remember the indices laws, as 1 plus x to the power of minus 2 like this, because when it's 1 over something you can write it as the power of minus 2, and as it's a negative number we need to, as n, we need to sub it into this formula here. So again, let's do it term by term. So the first term is always going to be 1, then the second term is nx, so it's going to be minus 2 x, and then the third term is going to be n, so it's going to be minus 2, and then it's going to be minus 2 minus 1 over 2 factorial of x squared. We can simplify this to minus 2 of minus 3 over, and then 2 factorial is just 2 again, and then x squared, and then the 2 can cancel out here to just give minus of minus 3, so it's just going to be 3 and then x squared. So this is going to be the third term. Then the fourth term is going to be n, so it's going to be minus 2, n minus 1, so minus 2 minus 1, and then minus 2 over 3 factorial, and then times x cubed. This is going to be equal to minus 2 times minus 3 times minus 4 over 3 factorial, which is equal to 6, and then x cubed, and this is going to be equal to minus 2 times minus 3 is going to be equal to 6, and then it's times minus 4 over 6 like this, which is x cubed, and then the 6's here can cancel out in order to give minus 4 x cubed. It wants us to go up to the x cubed term, so this is enough. So therefore this is going to be equal to, and then we add these terms together, it's going to be 1 minus 2x plus 3x squared minus 4x cubed like this. And then this is the answer. This is the expansion up to including the x to the power of 3 term. I just want to remind you again that the values of x that we sub in, the modulus of them has to be less than 1. Here's another example, but this time we have a coefficient in front of the x here. So the approach to this is very similar, but we just sub in this entire value here as x in each part of the formula where we need x. So we're going to sub in 3x wherever x is. So if we do this, the first term is still just going to be 1, then the second term is going to be nx, so it's going to be 3 over 4, because n is equal to 3 over 4, times x, and what we do is we sub 3x in as x like this. Then this is going to be equal to, if you simplify it, 3 times 3 is equal to 9 over 4, x like this. The third term is going to be 3 over 4, then 3 over 4 minus 1, over 2 factorial, and then we sub in 3x as x, so it's going to be 3x squared like this. Remember to include the 3 in the squared bracket as well, because remember it's x squared, so it's going to be 3x squared. The 3 is included. We can simplify this to 3 over 4 times minus 1 over 4 over, and then 2 factorial is just 2. This is multiplied by 9x squared, because 3 squared is equal to 9, and we can simplify this to minus 3 over 16 over 2, and then 9x squared. Then this is equal to minus 3 over 32 of 9x squared, and then this is going to be equal to minus 27 over 32 x squared. So this is the x squared term. Then the x cubed term is going to be 3 over 4 minus 1, 3 over 4 minus 2 over 3 factorial multiplied by 3x to the power of 3. Now this is quite long, I'm just going to put it into the calculator. Remember to include the 3 cubed in the coefficient that you're going to do. Remember, another way that you could write this is 3 cubed like this, and then x cubed. This whole thing here is what you're going to put into your calculator, and then if you do put this into your calculator, you get a value of 135 over 128. X to the power of 3. So therefore this bracket, the first up to including the x to the power of 3 term, if you add these terms together, it's going to be 1 plus 9 over 4x minus 27 over 32 x squared plus 135 over 128 x to the power of 3 like this. Now there's one other difference when there is a coefficient in front of x, and with the value of x that we have here, we also have to sub this in here to get the set of values that we can use. So we're going to sub in the modulus of 3x is less than 1, and we can rearrange this to by just timesing it together like this. This is 3x, it's the modulus of 3 times the modulus of x is less than 1. The modulus of 3 is just 3, and times the modulus of x is less than 1. Then divide both sides by 3 to get that the modulus of x needs to be less than 1 over 3. So now the only values of x that can be subbed in now is when the modulus of x is less than 1 over 3 instead. So we have a smaller set of values. So for example, if we wanted to sub in x is equal to 2 over 3, for example, we could have done that in the previous question, because the previous question we're using this set of values where it can be less than 1, but now it has to be less than 1 over 3. And because 2 over 3 is bigger than 1 over 3, therefore we cannot sub this into this expression here for this bracket. It doesn't work, it doesn't fall in the set of values that we can use. So here's another example question where there's a coefficient of x in the expansion. So for part A, we need to find the first 4 terms in ascending powers of x in this expansion. So as it's the first 4 terms in ascending powers of x, it's going to be this term, this term, this term, and this term. So it's going to go up to x to the power of 3. So the first thing we need to do is rewrite this as 1 minus 2x to the power of minus, because it's the 1 over, and then it's going to be a half because we've got this square root down here. And then we do the expansion of this, but we sub in minus 2x as the value of x. Please remember the minus here as well, because normally this is plus. So to consider this, we need to put the minus in, and that's what we need to sub in. So let's do it term by term. So the first term is going to be 1. The second term is going to be n, which is minus a half, times x, which is the minus 2x here, which is equal to just x like this. And then the third term is going to be minus a half then minus a half minus 1 over 2 factorial, and then it's going to be minus 2x squared. Remember to put the minus in as the squared here, because you need to put this whole thing here as x, including the minus. So this is going to be equal to minus a half, and then it's going to be minus 3 over 2 like this. 2 factorial is just 2, and then it's going to be 4x squared like this. We can simplify this, so this is going to be 3 over 4 over 2, and then it's going to be 4x squared, and then this is going to be equal to 3 over 8 times 4x squared, and then this is going to be equal to, so the 4 and the 8 cancel out, and this is just going to become 2, so it's going to be 3 over 2x squared like this is the third term, and the fourth term is going to be minus a half minus 1 minus a half minus 2 over 3 factorial, and then minus 2x to the power of 3, which if you just put all of this into your calculator, you get out the value of 5 over 2x cubed. So the first 4 terms of this expansion here is these terms added together. So it's going to be 1 plus x plus 3 over 2x squared plus 5 over 2x cubed. And then for part B, we need to state the set of values for which this expansion is valid for. So what we need to do is we need to sub this minus 2x here into here to get to modify this in order to do it. So it's going to be the modulus of minus 2x like this. Remember, we sub the minus 2x as the x is less than 1, which we can write as the modulus of minus 2 times the modulus of x is less than 1, which is just going to be 2 times the modulus of x is less than 1, so therefore it's going to be the modulus of x is less than a half. So the values of x that we can sub in is when the modulus of x is less than a half. You might notice that it's the same valid solutions that we can sub in for x if it's 1 plus 2x, or in this case 1 minus 2x, because of the way the modulus works, it doesn't matter if it's a plus or a minus here, we get the same values that we can sub in for in order for it to work. Here's a special type of question I've seen asked a couple of times, where we have a normal bracket here, and then we have this bracket with either a fraction or a negative number as a power. And this isn't too bad. All we just need to do is the binomial expansion on this bracket, and then whatever terms we get out, we just expand it by this bracket here. So let's focus on this first. So firstly, we need to do the binomial expansion of 1 plus 2x to the power of 3 over 2 like this, and we're going to use this formula here. So the first term is just going to be 1, the second term is going to be nx, so it's going to be 3 over 2 is n, and then x is this 2x here, so this is going to be equal to 3x like this, and then the third term is going to be n, so it's going to be 3 over 2, then 3 over 2 minus 1, and this is over 2 factorial, and then it's 2x squared. Remember to include the 2 in the squared part, and this is going to be equal to 3 over 2 times a half over 2 factorial, which is just 2, and then 2x squared, so it's going to be 4x squared like that, and this is going to be equal to 3 over 4 over 2 of 4x squared, and this is going to be equal to 3 over 8 of 4x squared, so this is going to be equal to 3 over 2 of x squared. So this is going to be the third term. Then the fourth term is going to be 3 over 2, and then 3 over 2 minus 1, 3 over 2 minus 2 over 3 factorial multiplied by 2x to the power of 3, and because this is quite long, I'll just put it into the calculator, and this is equal to minus a half x to the power of 3 like this. So therefore this expansion here is equal to 1 plus 3x plus 3 over 2 x squared minus a half x cubed, and then we need to multiply this by the 2 plus x, because it's these two multiplied together. So therefore it's going to be 2 plus x, so this bracket here, multiplied by this bracket, which we got equal to this, up to including the x to the power of 3 term. So it's going to be 2 plus x times 1 plus 3x plus 3 over 2 x squared minus a half x cubed. So now we just need to expand the brackets. Let's start with the 2 and then all of this together. So it's going to be 2 plus 6x plus 3x squared, because it's going to get rid of the 2 down here, minus x cubed, and then it's going to be the x times all of these, so it's going to be plus x plus 3x squared plus 3 over 2x cubed, and then it's going to be minus a half x to the power of 4. But because we're going only up to the x to the power of 3 term, we don't actually really need to include this, because that's going beyond what we need to do, x to the power of 4. So we only can just go up to this, and then we can simplify this by collecting like terms. So it's just going to be the 2 here, and then it's going to be 6x plus x, which is going to be 7x. There's going to be 3x squared plus 3x squared, which is going to be 6x squared. And then it's going to be 3 over 2 x to the power of 3 minus x to the power of 3, which is going to be plus a half x to the power of 3. So therefore, this here, 2 plus x, and then 1 plus 2x to the power of 3 over 2, is going to be equal to this here. In year 1, we talked about binomial estimation. I won't go over the complexities here, go back to that video if you need to, but using binomial expansion, we can find approximate values for quite complex powers, and we can do the same for year 2 as well, with this formula and for fractions or square roots. And there's a very particular style of question that's very common for this chapter that we'll go over here, that's slightly different to the last chapter. So here's an example question. So for part A, we need to expand 1 minus x over 2 to the power of a half. Now, a lot of questions write it this way. I prefer to write it as 1 minus a half x to the power of a half, like this, because that's clearer to see what the coefficient at the front is. So therefore, we're going to sub all the values in with this here, minus a half x as the value of x. So the first term, we're going up to x to the power of 3. The first term is just 1. The second term is nx, so it's going to be half, and then it's going to be x, which is minus half x. Please remember to include the minus in this, which is going to be equal to minus a quarter x, like this. And then the third term is going to be half, then it's going to be half minus 1 over 2 factorial, and then it's going to be minus a half x squared, and this is going to be equal to half, and then it's going to be minus a half here over 2, and then it's going to be minus a half squared, so it's going to be a positive quarter x squared, like this, and this is going to be equal to minus a quarter over 2 times a quarter x squared, which is going to be equal to minus 1 over 8 1 over 4x squared, which is going to be equal to minus 1 over 32x squared, like this. So this is going to be the third term. Then the fourth term is going to be half minus 1, half minus 2 over 3 factorial, and then minus a half x, and then cubed, like this. And then I'm just going to put this into a calculator. If you put it into a calculator, it's equal to minus 1 over 128 x cubed. So this bracket here is equal to all these terms added together. 1 minus a quarter x minus 1 over 32 x squared minus 128 under 1x cubed. So for part B, this is a really common exam question they like to ask for this chapter, and I used to get this question wrong all the time at A-level, because I think this is actually kind of a bit of a misleading question with the way that this is written, so I'd be really careful with this and remember how this works. So what the question is asking is, by substituting x is equal to 0.5, it wants us to find an approximation of root 3. Now, when I was in A-level, the way I used to read this is, by substituting in x is equal to 0.5, you will get an approximation for root 3. And this isn't actually the case. You don't just sub this in and get the answer. You have to do other stuff as well, and I'll show how to do it. So just be careful with this. So firstly, let's actually sub x is equal to 0.5 into this. So this is going to be 1 minus a quarter, and then x is equal to 0.5 minus 1 over 32 of 0.5 squared minus 1 over 128 of 0.5 cubed. And if you put this into a calculator once it's to 3 decimal places, you get out a value of 0.866. So this is 0.866 when you sub in the value of x is equal to 0.5. And I used to think that that's just the answer. You sub this in, you get this out of the answer, and this is approximate value of 0.3. And that's not the answer. And the reason is because you need to consider what happens when you sub in x is equal to 0.5 into this bracket here. So this is going to be 1 minus a half of x. Remember, x is 0.5. Another way we can write this is a half, so we can get brackets together. So the power of a half, and this is equal to 1 minus a quarter of a half, which is equal to 3 over 4 to the power of a half, like this, which is of course equal to the square root of 3 over 4. And we can split up the square root into root 3 over root 4 like this, which is equal to root 3 over, and then root 4 is 2. So when we sub x is equal to 0.5 or a half into this bracket here, we get out the value of root 3 over 2. So when we sub in x is equal to 0.5, we're getting an approximate value of root 3 over 2 here. We're not getting the approximate value of root 3. The way that we get the approximate value of root 3 is by timesing both sides by 2 to get rid of this denominator here. So this side just becomes root 3, and then we times this side by 2 to get, if you put it into a calculator, 1.732. And this is the approximate value of root 3, and this is the final answer. Root 3 is approximately equal to 1.732. So be careful with a question like this. Consider what happens when you sub x is equal to 0.5 into this bracket here. Do you actually get out the thing that you're trying to find the approximate value of? A lot of the time you won't, you'll get something else. So what you need to do is, in this case, times it by 2 in order to get from root 3 over 2 to root 3 like this. And if you put root 3 into your calculator, 2 3 decimal places, you get out 1.732. So it's a really good approximation. Just note, the reason it is an approximation is because we've only used the first 3 terms, and we haven't used, like, theoretically you should use all the terms, which I know you can't do because it goes on forever, but that's how you would actually get the exact answer. This is only an approximate value. If you did more decimal places, you would find that this is not exactly equal to root 3. So all the examples we've gone through so far is when this first number here is 1. So what if it's not 1, like this example here, where we need to expand the root of 4 plus 8x? So the way we would do this is basically we need this first number here in order to be 1, in order to use this formula here. And the way that we can make it 1 is by factorization. So let's write this in the indices form, in the kind of bracket form like this. So it's going to be 4 plus 8x to the power of a half, because remember, a half is a square root like this. And what we're going to do is this expression here, we're going to factor out 4 in order to make this number 1 out of this whole expression. So this is going to be equal to 4, and then it's going to be 1 plus 2x, and all of this is to the power of a half. So we factored 4 out of this expression here to make it 1 plus 2x. We need to affect this number here as well. And importantly, I always used to forget this. This 4 is still in the bracket. This is, if you wanted to write it as a square root instead, you can. This 4 is still affected by this power here. Please don't forget that. And then what we can do is affect this 4 individually by this power. So it's going to be 4 to the power of a half, so it's going to be the square root of 4. So it's going to be 2, and then 1 plus 2x to the power of a half like this. So we've taken this 4 outside of the bracket by affecting it by this power here to make it 2. And what we have now is we have this bracket here, which is of the form 1 plus x to the power of n. So therefore we can expand this, find everything up to the x to the power of 3 term, and then just multiply it by this in order to get the expansion of this. So therefore it's going to be 1 plus 2x to the power of a half. So let's do this. So the first term is going to be 1. The second term is going to be nx. So it's going to be a half times x, and x is 2x in this instance, which is equal to x. And then the third term here is going to be a half, and then a half minus 1 over 2 factorial, and then x, which is 2x squared like this, and this is going to be equal to a half minus a half just 2 down here because 2 factorial is just 2, and then 4x squared, and this is going to be equal to minus a quarter over 2 4x squared, which is going to be equal to minus 1 over 8 4x squared, which is going to be equal to minus half x squared, like this. And then the third term is going to be half, then half minus 1, half minus 2 over 3 factorial, and then it's going to be 2x to the power of 3. And then if you just put this into your calculator, it gives out half, and then it's going to be x cubed. So therefore, this expansion here of this binomial expansion is going to be, so this 2 here is still at the front, and then this expansion is going to be these terms added together. So 1 plus x minus a half x squared plus a half x cubed. So this is this expanded here, and therefore we just multiply everything by 2, expand the bracket to get 2 plus 2x minus x squared plus x to the power of 3, like this. And this is the final answer. This expanded here, 4 plus 8x to the power of a half, is this expression down here. Now, because there's a coefficient of x, we need to sub in a value up here to get the new set of values if it asks for it. And we would sub in this here. The reason we would sub in this is because this is what we've subbed into the formula, 1 plus 2x. So therefore we would sub 2x in as this value here. Don't make the mistake of subbing in 8x into this here. It would be whatever we actually put into the formula. So it would be this bracket here. So therefore it's going to be the modulus of 2x is less than 1. So therefore it's going to be the modulus of x is less than a half. So this is the set of valid things that you could put in for x, which you could put into this expression here. Don't use 8x, use the actual bracket that is put into the equation like this. Just another note as well, you might be thinking here that we've done 4 square root of 4, which is equal to 2. You could be thinking we do the positive and negative square root, so it could be minus 2 as well. And it could be, as this would of course give the negative square root. Remember, you could technically have a positive or negative square root here. For this though, we'll just assume and just figure out the positive square root and just do that for all of them. Here's another example where the first term in the bracket is not 1, and therefore you have to factorise. So for part A, first of all, let's write this as 2 minus 5x to the power of minus 2 because it's under 1 like this. And now let's factorise out the 2 from this expression in order to get it into this form. So it's going to be 2, and then it's going to be 1 minus 5 over 2x like this, and then this is to the power of minus 2, and then this 2, remember, is still inside this power, so therefore we need to do 2 to the power of minus 2 to move it outside of the bracket, and this is going to be 1 over 4, and then 1 minus 5 over 2x to the power of minus 2 like this. And then what we do is we do the binomial expansion on this here, 1 minus 5 over 2x. So the first term, because we're going up to x to the power of 3, it's going to be 1, and then the second term is going to be minus 2, which is n times x, which is minus 5 over 2x, which is equal to 5x, and then the second term is going to be n, which is minus 2 minus 1 over 2 factorial, and then minus 5 over 2x squared, which is equal to minus 2 minus 3 over 2, and then 25 over 4 x squared, and this is equal to, so this 2 here is going to cancel out, and these negatives are going to cancel out as well to just leave 3 here, so it's going to be 3 times 25 over 4x squared, which is therefore going to be equal to 75 over 4 x squared. And then the fourth term here is going to be n, which is minus 2, then minus 2 minus 1, minus 2 minus 2 over 3 factorial times minus 5 over 2x cubed. And I'm just going to put this into the calculator, and if you put this into a calculator, you get out a value of 125 over 2 x to the power of 3. So this is the bracket that we've expanded, so therefore this here is going to be equal to 1 over 4, and then these 4 terms, so 1 plus 5x plus 75 over 4x squared plus 125 over 2x cubed, like this. And then what we're just going to do is expand the bracket with the 1 over 4, so it becomes 1 over 4 plus 5 over 4x plus 75 over 16x squared plus 125 over 8x cubed. And this is the final answer. This bracket here expanded, or this one, is equal to this expression here. And then for part B, we need to state the set of values for x to which this expansion is valid. So remember, we don't plug this in, this value here. We plug in this value because this is the actual bracket that we put into the formula here. So therefore, we're going to substitute minus 5 over 2x into here. So it's going to be the modulus of minus 5 over 2x is less than 1. So therefore, it's going to be the modulus of minus 5 over 2 times the modulus of x is less than 1, so therefore it's going to be 5 over 2 times the modulus of x is less than 1. So therefore we're going to divide both sides by 5 over 2, which is going to be that the modulus of x is less than 2 over 5. So the set of possible values to which the expansion is valid is when the modulus of x is less than 2 over 5, or 0.4. Finally, I want to talk about partial fractions. It's common for a question to give you a function and then they want you to split it up into partial fractions and then do a binomial expansion. There's nothing new here, it's just combining this chapter with the skills of partial fractions. So go back to the video on partial fractions if you need to. So here's a question on this. So for part A, we need to do the actual thing of splitting it into partial fractions. I'm not going to go into detail of how this works, so again, go back to the video on partial fractions if you need to. Firstly, I'm going to multiply everything by the denominators here. So this cancels out to just become 7, and then this will cancel out to just leave A, and then 1 minus 2x, and then plus b, and then this denominator will cancel out, and then it will just leave with b times 2 plus 3x, like this. And then I'm going to do it by substitution. So firstly, I'm going to let x equal a half, so therefore this here is going to be equal to 0, so therefore it's going to be 7 is equal to, and then this goes away, and then we're just left with b times, and then it's going to be, when you sub 2 plus 3 of a half into this, it's going to be 7 is equal to b, so it's going to be 2 plus 3 over 2, so therefore it's going to be 7 is equal to 7 over 2b, so therefore divide both sides by 7 over 2 to get b is equal to 2. So b is equal to 2, and therefore a, if we let x equal minus 2 over 3, so therefore this cancels out here, so therefore it's going to be 7 is equal to a of 1 minus 2 of minus 2 over 3, like this. So this is going to be 7 is equal to a, and then it's going to be 1 plus 4 over 3, like this, because the two negatives cancel out, and then it's going to be 7 is equal to 7 over 3a, and then divide both sides by 7 over 3 to get a is equal to 3. So therefore a is equal to 3 and b is equal to 2. And then for part B, we need to expand f of x up to including the x squared term. When it's partial fractions, it's quite common for them to want you to go up to the x squared term, so the x to the power of 3, because we have 2 brackets here, so there's less work to do per bracket. So first of all, let's write this as 3 of 2 plus 3x to the power of minus 1 plus 2, and then 1 minus 2x to the power of minus 1, like this. And then let's do both of these individually. So let's start with this one. So 2 plus 3x to the power of minus 1. And we need this first number here to be 1, so we need to factorize. So let's factorize the 2 out, so it becomes 2 of 1 plus 3 over 2x to the power of minus 1, like this. And then what we need to do is this 2 needs to be raised to the power of minus 1 to get it out of the bracket, so it's going to become half of 1 plus 3 over 2x to the power of minus 1, like this. Okay, and then what we need to do is do the binomial expansion on this here. So it's going to be 1 as the first term, then the second term is going to be n, which is minus 1 times x, which is 3 over 2x, which is equal to minus 3 over 2x, like this. And then the next term is going to be minus 1, then minus 1 over 2 factorial of 3 over 2x squared, which is equal to minus 1 minus 2 over 2 of 9 over 4x squared, which is equal to, and then the 2's cancel out, and the minuses also cancel out, so all of this cancels out to just leave 9 over 4x squared. So therefore, this bracket here is equal to, remember to leave the half here, this bracket is equal to 1 minus 3 over 2x plus 9 over 4x squared. Remember again that we only need up to the x squared term here. And then we expand the brackets, expand the half to do half minus 3 over 4x plus 9 over 8x squared. So this bracket, 2 plus 3x to the power of minus 1 is equal to this. And then let's expand this bracket here. So this is 1 minus 2x to the power of minus 1 like this. So the first term is going to be 1. The second term is going to be minus 1 times x, which is minus 2x, which is equal to 2x. Then the third term is going to be minus 1 and then minus 1 over 2 factorial of minus 2x squared, which is equal to minus 1 minus 2 over 2 of 4x squared, which is equal to, and then the 2's cancel out and the minuses cancel out again, so this whole thing goes away, so we're just left with 4x squared. So therefore this here, 1 minus 2x to the power of minus 1 is equal to 1 plus 2x plus 4x squared, up to including the x squared term. And then all we need to do now is plug these in, the 2 over 3x to the power of minus 1 and the 1 minus 2x here into this, and then expand the brackets. It's going to be equal to 3 and then 2 minus 3x to the power of minus 1, so it's going to be half minus 3 over 4x plus 9 over 8x squared. That's going to be plus 2, and then it's going to be 1 plus 2x plus 4x squared, and this is going to be equal to, and then we expand this to become 3 over 2 minus 9 over 4x plus 27 over 8x squared. That's going to be plus 2 plus 4x plus 8x squared, and this is all going to be equal to, if you figure it out, 7 over 2 plus 7 over 4x plus 91 over 8x squared. That's the final answer. This whole thing expanded here is equal to 7 over 2 plus 7 over 4x plus 91 over 8x squared. Now for part C, we need to find the set of values for x which the expansion is valid for. Now this is a bit different from before because now we have done 2 binomial expansions. So which one do we pick? So first of all, let's actually figure out each one individually. So let's start with the 2 plus 3x to the power of minus 1. So this was this binomial expansion. And remember, we wrote this as a half of 1 plus 3 over 2 x to the power of minus 1. This is what we actually plugged into the formula, so remember this is actually the one that we plug into this here as well. So therefore it's going to be the modulus of 3 over 2x is less than 1, so therefore it's going to be the modulus of x is less than 2 over 3, like this. So this is the set of values that we can use for this individual one here, and then this one is 1 minus 2x to the power of minus 1. We didn't do any factorisation, so therefore we sub minus 2x into this here, so it's going to be the modulus of minus 2x is less than 1, and then remember that the modulus of minus 2 is just 2, so therefore it's going to be the modulus of x is less than a half, like this. So we have a set of 2 different values here. So which one do we pick? Well, we always have to pick the smallest set of values, and a half is smaller than 2 over 3, so we have to pick this one, because if we want to put a value of x into this whole expression here, it has to satisfy both of the conditions and both of these brackets here, because we've made it up of both of these. So therefore we can only use this set of values for this expansion. If we chose this set of values instead of this bigger set of values, let's say we wanted to sub in a value less than this, minus 2 over 3, but bigger than half, so something like x is equal to 0.6, something like that. It would work for this bracket, but it wouldn't work for this bracket because 0.6 is bigger than a half, so therefore it would only work for one of them. Because this expression is made up of both of these brackets, therefore for the expression as a whole, you couldn't sub in this value, it doesn't work. We have to pick the smallest set of values, so the modulus of x is less than a half, so therefore it is contained within both the set of values and both of the brackets are satisfied, so therefore the whole expression is satisfied. So here's another example of partial fractions and then binomial expansion. So for part A, we need to find the values of the constants A, B and C, so we just need to split it up into partial fractions. So firstly, multiply everything by the denominator here, so it becomes 25 is equal to, and then the 2 plus x cancels out to give A of 1 minus 2x squared, plus B, and then 1 of the 1 minus 2x's cancels out to give B of 1 minus 2x of 2 plus x, and then it's going to be plus C of, and then both the 1 minus 2x's cancels out to give C of 2 plus x, like this. Okay, firstly, let's say that x is equal to a half, so therefore these brackets cancel out and become 0, so it's just going to be 25 is equal to C of 2 plus a half, so it's going to be 25 is equal to 5 over 2c, so therefore c is going to be equal to 10. And then we're going to let x equal minus 2, so therefore this bracket cancels out, so therefore it's going to be 25 is equal to a of 1 minus 2 of minus 2 squared, so therefore it's going to be 25 is equal to a of 1 plus 4 squared, so it's going to be 25 of 5 squared of a, so it's going to be 25a, so therefore it's going to be a is equal to 1. So now we're a bit in an awkward situation because we can't sub any of the values in to make the brackets 0 because this has both of the brackets. So firstly, let's sub in the values of c and a that we've got so far. So it's going to be 25 is equal to a, so it's 1, so it's going to be 1 minus 2x squared, plus b, which is, we don't know yet, so it's going to be b of 1 minus 2x, 2 plus x, like this, and then it's going to be plus c, which is 10 of 2 plus x, like this. Now you could equate the coefficients from here. The way that I would do it is just sub in another value of x and then just do it from there. So I'm just going to say let x equal to 1, for example, so therefore it's going to be 25 is equal to, and then if you sub 1 into here, you're going to get out 1 in here if you sub x as 1. And then it's going to be plus b of 1 minus 2x, which is going to be equal to, if you sub in 1, it's going to be minus 1, and then 2 plus x, which is going to be 3, and then it's going to be 10 times 2 plus x, so it's going to be 10 times 3, like this, if you sub in x is equal to 1. Do some simplifying, so it's going to be 25 is equal to 1, minus 1 times 3 is minus 3, so it's going to be minus 3b, and then plus 30 like this, so it's going to be 25 is equal to 31 minus 3b. Move the 31 onto the other side to get minus 6 is equal to minus 3b, and divide both sides by minus 3 to get b is equal to 2. So those are the values of a, b and c. A is equal to 1, b is equal to 2, and c is equal to 10. So for part B, you'll need to expand f of x up to and including the x squared term. As I said before, it's quite common for them to ask for partial fractions to up to the x squared term. So the x to the power of 3, because we're doing 3 different expansions in this case, so there's less work per bracket. So first of all, let's write this as 2 plus x to the power of minus 1 plus 2, and then 1 minus 2x to the power of minus 1 plus 10, and then 1 minus 2x to the power of minus 2, and then we have 3 different expansions that we need to do. So this first one here is going to be 2 plus x to the power of minus 1. So we need to factor out the 2 in order to make this first number 1. So this is going to be equal to 2, and then 1 plus a half x to the power of minus 1. Then we take the 2 out of the brackets by affecting it by this power here, so it's going to be equal to a half, because that's 2 to the power of minus 1. Half of 1 plus half x to the power of minus 1, and then we binomial expand this here. So this is, so the first term is going to be 1, the second term is going to be minus 1 times half x which is going to be equal to minus a half x. And the third term is going to be minus 1, minus 1, minus 1, and over 2 factorial, and then half x squared. This is going to be equal to minus 1 minus 2 over 2 of 1 over 4 x squared, like this. And this is going to be equal to, so the 2 is going to cancel out here and the negatives are going to cancel out as well to give 1 over 4 x squared. So therefore this is going to be equal to, the half still going to be here, so this expanded here is a half times 1 minus half x plus a quarter x squared, like this. And then we expand this to do a half minus 1 over quarter x plus 1 over 8 x squared. So this expanded 2 plus x to the power of minus 1 is this here. And now let's expand this bracket here. So this is going to be 1 minus 2x to the power of minus 1. So the first term is going to be 1. The second term is going to be minus 1 times and then minus 2x, which is equal to 2x, like this. And then it's going to be minus 1, minus 1, minus 1 over 2 factorial of minus 2x squared, which is equal to minus 1 minus 2 over 2 of 4x squared, which would be equal to, so the 2 cancels out and the negatives cancel out, just leave 4x squared. So this here is equal to 1 plus 2x plus 4x squared. And then finally, let's expand this here. So this is going to be 1 minus 2x to the power of minus 2. So the first term is going to be 1. The second term is going to be minus 2, then minus 2x, which is equal to 4x. And then it's going to be minus 2 minus 1 over 2 factorial of minus 2x squared, which is equal to minus 2 minus 3 over 2 of 4x squared, which is going to be equal to, the 2 is going to cancel out like this and the negatives are going to cancel out as well to give 3 times 4x squared, which is equal to 12x squared. So this here is equal to 1 plus 4x plus 12x squared. And now we just need to sub everything in. So let's start with this here. So this is 2 plus x to the power of minus 1. So this is half minus a quarter x plus 1 over 8x squared, and then it's plus 2, and then the 1 minus 2x to the power of minus 1, so it's going to be 1 plus 2x plus 4x squared, and it's going to be plus 10, and then this here, so this is going to be 1 plus 4x plus 12x squared, and then this is going to be equal to, if we expand the bracket, so this is still a half minus a quarter x plus 1 over 8x squared plus 2 plus 4x plus 8x squared, and then it's going to be plus 10 plus 40x plus 120x squared. And if you simplify all of this and figure it out, you will get out an answer of 25 over 2 plus 175 over 4x plus 1025 over 8 x squared. So this function here, f of x, when you expand it and simplify it down to this, it's equal to this expression here. And then for part C, we need to find the set of values of x that can be used in the expansion. So we need to find the individual set of values that can be used and then use the smallest set of values. So firstly, let's focus on this bracket here. Now remember, this here is the actual bracket that we subbed into the formula. So therefore, this value is the one that we're going to sub in here. So it's going to be the modulus of half x is less than 1, so therefore it's going to be the modulus of x is less than 2. And then this bracket here, this was already 1, we didn't do any factorization, so therefore this is going to be the modulus of 2x has to be less than 1, so therefore it has to be the modulus of x is less than a half. Remember, it's the modulus of minus 2 is just 2. And then this one here is the same, the modulus of minus 2x has to be less than 1, so therefore the modulus of x is less than a half. And remember, we picked the smallest set of values, so therefore it's not going to be this one because this is too big. It's going to be this, that the modulus of x is less than a half. This one here is too big, so we have to pick the smaller ones. So this is the final answer. Because this is quite a long video and we've covered a lot of content, we've obviously covered the whole of chapter 4 in the textbook, I've included 3 questions here to have a go at. Again, I've given you the formula for the expansion of 1 over x to the power of n, because again, this is given to you in the formula booklet, so you have access to it in the exam. So pause the video, have a go, and I'll go through the answers in about 5 seconds. So for part A, we need to expand this here. So this is 2 minus 3x to the power of minus 2, like this. Now we need to factorize this in order to make the first number 1. So this is going to be equal to 2, and then 1 minus 3 over 2 x to the power of minus 2, like this. Remember, this 2 is still in this bracket here, so to get it out we need to affect it by this power here. So it's going to be 2 to the power of minus 2, so it's going to be 1 over 4, 1 minus 3 over 2 x to the power of minus 2, like this. And then we can plug this into this formula here. So what we're going to do, the first term is going to be 1, the second term is going to be nx, it's going to be minus 2 of minus 3 over 2 x, which is equal to 3x, and then the next term is going to be minus 2 of minus 2 minus 1 over 2 factorial of minus 3 over 2 x squared, which is going to be equal to minus 2 minus 3 over 2 of 9 over 4 x squared, which is equal to, so these 2's are going to cancel out and then the negatives are going to cancel out as well, to give 3 of 9 over 4 x squared, which is equal to 27 over 4 x squared. So this is the next term, and the term after that is going to be minus 2 of minus 2 minus 1 minus 2 minus 2 over 3 factorial. Please remember the factorial here, so it's going to be 6, 3 times 2 of minus 3 over 2 x cubed. I'm just going to put this into a calculator, it's quite long. If you put it into a calculator, you get an answer of 27 over 2. And then x to the power of 3. So therefore this here is going to be equal to, so it's 1 over 4 of 1 minus 3 over 2x. So it's going to be equal to these terms added together. So 1 plus 3x plus 27 over 4x squared plus 27 over 2x cubed. So this is going to be equal to, if we expand the bracket, it's going to be equal to a quarter plus 3 over 4x plus 27 over 16 x squared plus 27 over 8 x cubed. So this bracket here is equal to this expression here, where we're going up to and including the x to the power of 3 term. So for part B, we're given this function here, and we're told that the coefficient of x is 0 and the coefficient of x squared is 9 over 16 for this function here when you expand it. We need to find the value of a and the value of b. So first of all, we can rewrite this here as a plus bx times 2 minus 3x to the power of minus 2, because you have these squared denominators and come up to the power of minus 2. So therefore, as this is 2 minus 3x to the power of minus 2, this is just a plus bx multiplied by this expression here. And we're told the coefficient of x is 0 and the coefficient of x squared is 9 over 16. Now, rather than just expanding this and doing a load of maths that we don't need to do, let's just individually consider the coefficient of x and the coefficient of x squared. So let's start with the coefficient of x. So the x terms when this is multiplied by this is going to be when a multiplies 3 over 4x to get 3 over 4ax, and when bx multiplies 1 over 4 to get 1 over 4 bx, like this. These are going to be the only x terms that are going to be present when this multiplies by this. So therefore the coefficients are 3 over 4a plus 1 over 4b, and this is equal to 0. Now let's focus on x squared, and the only x squared terms that are going to be present are going to be when a multiplies 27 over 16 x squared to give 27 over 16 a x squared, and when bx multiplies 3 over 4x to give 3 over 4 bx x squared. These are going to be the only x squared terms that are present in this expansion. There's no other way that an x squared term can exist with the way that things are multiplied together. So therefore, the coefficients are 27 over 16a plus 3 over 4b, and this is equal to 9 over 16. And now we have a pair of simultaneous equations. We have 3 over 4a plus 1 over 4b is equal to 0, and 27 over 16a plus 3 over 4b is equal to 9 over 16, like this. And we can solve these simultaneous equations because we know how to solve simultaneous equations before. Now, firstly, I'm just going to multiply everything by 16 so we can get rid of these 4 and 16 denominators here. So we multiply this by 16, it's going to be 3 over 4 times a times 16, which is going to be equal to 12a. If you don't know what I've done there, it's going to be 3 over 4a times 16. So therefore the 4 and the 16 are going to cancel out to leave 1 here, so no denominator, and 4 here. So it's going to become 3a times 4 like this, so therefore it's going to become 12a. One of the 4's in the 16 cancels out the denominator, and then the other one multiplies the 3. So it's going to be 12a plus, and then it's going to be 1 over 4b times 16, which is going to be 4b. And this is equal to 0, and then the other simultaneous equation is going to be 27a plus, and then it's going to be 3 over 4 times 16 is going to be 12b, and this is going to be equal to 9. And what we're going to do is we're going to times this one up here by 3, so therefore we get 12b present in both of the simultaneous equations. So it's going to become 36a plus 12b is equal to 0, and 27a plus 12b is equal to 9. And now we have this 12b here, so therefore we can just minus this simultaneous equation from this one. So it's going to give 9a, and then the 12b is going to cancel out, and then it's going to be 0 minus 9. Be careful with the minuses here. It's going to be 0 minus 9. So 9a is going to be equal to minus 9, so therefore a is going to be equal to minus 1. So a is equal to minus 1, and then we can figure out b by just subbing a into a simultaneous equation. We'll just use this one here. So it's going to be 12, and then a is minus 1, plus 4b is equal to 0. So it's going to be minus 12 plus 4b is equal to 0. So it's going to be 4b is equal to 12, so therefore b is going to be 12 divided by 4, which is going to be 3. So a is equal to minus 1 and b is equal to 3. We've solved the simultaneous equations. Now remember, you can use your calculator to check results of simultaneous equations by putting in the a as the x and the b as the y, and it also gives out that a is equal to minus 1 and b is equal to 3. And then for part C, we need to find the coefficients of x to the power of 3. And now we know the values of a and b, we can just sub it into here. So it's going to be a, so it's minus 1 plus 3x, which is b, multiplied by 2 minus 3x to the power of minus 2, like this. And therefore what we can do is we can find the coefficients of x to the power of 3 by considering this multiplying by this. So the coefficients of x to the power of 3 is going to be when minus 1 multiplies 27 over 8x to the power of 3 to give minus 27 over 8x to the power of 3, and when 3x multiplies 27 over 16x to the power of 2 to give 81 over 16 x to the power of 3, like this. And if you put this into a calculator, it gives out the value of 27 over 16 x to the power of 3. So the coefficient of x to the power of 3 in a simplified fraction is 27 over 16. So for question 2 part A, we're given this function here, and we basically just need to split it up into partial fractions to find the value of b and c, and we need to show that a is equal to 0. So first of all, let's multiply everything here by the denominator here. So it becomes on this side 27x squared plus 32x plus 16 is equivalent to, so one of the 3x plus 2's is used to cancel out this, so we're left with a of 3x plus 2 and 1 minus x plus b, and then both the 3x plus 2's are used to cancel out the denominator. It's going to be b of 1 minus x plus c, and then 1 minus x cancels out here to leave us with c of 3x plus 2 squared, like this. And then we can do some substitutions to figure out some values. So first of all, let's let x equal to minus 2 over 3. So therefore these brackets become 0. So therefore it's going to be, first of all, if you let x equal to 2 over 3 and sub it into here, you get out a value of 20 over 3 if you put it into your calculator for this side. And this is equal to, so these two become 0, so it's going to be b, and then 1 minus 2 over 3. So it's going to be 20 over 3 is equal to b of 1 plus 2 over 3. So it's going to be 20 over 3 is equal to 5 over 3 b. So therefore b is going to be equal to 20 over 3 divided by 5 over 3. So it's going to be b is equal to 4. And then we're going to let x equal to 1, so therefore this bracket becomes 0 and cancels out. So it's going to be, first of all, if you sub x is equal to 1 into here, you get 75 is equal to, and this cancels out and this cancels out, just leave with c of 3 times 1 plus 2 squared. So therefore it's 75 is equal to c of 3 plus 2, so it's going to be 5 squared. So therefore it's going to be 75 is equal to 25c, so therefore c is going to be equal to 3. So b is equal to 4 and c is equal to 3. Now we can't do a substitution to figure out a because it has both of these brackets, but what we can do is just sub in any other value for x, and therefore just figure out what a is by plugging in the values of c and b. So let's just let x just equal to 0. So on this side, if it's equal to 0, it's going to be equal to 16, and then it's going to be equal to, so if x is 0 here, it's going to be a times 2 times 1 plus b, which we know is 4, and then it's 1 minus x or 1 minus 0, so it's going to be 1 like this, plus c, which we know is 3, times, and then it's going to be, this here is just going to be 0, so it's going to be 2 squared like this. So we can do a lot of simplifying here. 16 is going to be equal to 2a plus 4 plus 3 times 4. So therefore it's going to be 16 is equal to 2a plus 4 plus 12. So therefore it's going to be 16 is equal to 2a plus 16. Move the 16 onto the other side to get that 0 is equal to 2a. So therefore a is also equal to 0. So we have found the values of b and c. B is equal to 4, c is equal to 3, and we have shown that a is equal to 0. So for part B, we need to expand f of x, and as we know, f of x is now equal to this, therefore we can do the binomial expansions of this. So let's rewrite this as 4, and then I'm going to write this the other way around to get it more into this form here. So it's going to be 4 of 2 plus 3x to the power of minus 2, and then it's going to be plus 3, and then it's 1 minus x to the power of minus 1 like this. So we have two brackets that therefore we're going to need to binomially expand. So let's start with this one here. So this is going to be 2 plus 3x to the power of minus 2. We need to make this number here 1, so let's factor out 2. So it's going to be 2 of 1 plus 3 over 2 x to the power of minus 2, and then let's put the 2 here to the power of minus 2 to give 1 over 4 of 1 plus 3 over 2 x to the power of minus 2 like this. And then what we can do is we can expand this. So the first term is going to be 1, second term is going to be minus 2, and then 3 over 2 x, which is equal to minus 3x, and then the next term is going to be minus 2 minus 1 of 2 factorial of 3 over 2 x squared, which is equal to minus 2 minus 3 over 2 of 9 over 4 x squared like this. This 2 cancels out with this, and the two negatives are going to cancel out to give 3 of 9 over 4 x squared, and this is equal to 27 over 4 x squared. So therefore we only need to go up to x to the power of 2 because it's a partial fraction, and therefore we have more work to do if we do x to the power of 3. So less work for each bracket. So therefore this here, 1 over 4 of 1 plus 3 over 2 x to the power of minus 2 is 1 over 4 of 1 minus 3x plus 27 over 4 x squared, which is equal to 1 over 4 minus 3 over 4 x plus 27 over 16 x squared. So this here, 2 plus 3x to the power of minus 2 is equal to this expression here. And then the next step is to expand this here, so 1 minus x to the power of minus 1. This number is already 1, so we don't need to do any factorise. This, the first term is 1, second term is minus 1 times minus x. Remember to include this minus here as the x, so this is equal to x, and then it's going to be minus 1, minus 1, minus 1 over 2 factorial of minus x squared. And this is equal to minus 1 of minus 2 over 2 of just x squared, because the minus goes away when you square it, and this is equal to, so the 2 cancels out this, and the 2 minuses go away, so this is just left with x squared. So 1 minus x to the power of minus 1 is equal to 1 plus x squared. And now we just need to sub the values into here. So it's going to be 4 of 2 plus 3x to the power of minus 2. So it's going to be 1 over 4 minus 3 over 4x plus 27 over 16 x squared. And it's going to be plus 3 of 1 minus x to the power of minus 1. So it's going to be 1 plus x squared, and this is equal to, if you expand the brackets, it's going to be 1 minus 3x plus 27 over 4x squared plus 3 plus 3x plus 3x squared. And then what you can do a load of simplifying here, and you will eventually get 4, and then you can see that it's minus 3x plus 3x, so this is just going to be plus 0x, which you don't really need to write, and then it's going to be 27 over 4x squared plus 3x squared, which is equal to 39 over 4x squared. So this here is equal to 4 plus 39 over 4x squared. So for part C, we need to find the percentage error of f of 0.2. So what happens when we sub x is equal to 0.2 in this compared to when we sub it into this. Now, percentage error was something we went through in the binomial estimation video. Percentage error is equal to the estimate. So the estimate is going to be using the approximate value that we get out of here, because again, we've only done up to the x to the power of 2, but obviously there's so many more terms than that. So therefore this is only an estimate, minus the actual value. So the actual value that you put into that you get out of the calculator when you sub in x is equal to 0.2 into f of x here, over the actual times 100. So let's figure out the estimate. So the estimate is going to be what happens when you sub in when you sub in x is equal to 0.2 into here. So it's going to be 4 plus 39 over 4 of 0.2 squared, and if you put this into a calculator, it's equal to 4.39. So this is the estimate, and then the actual is what happens when you sub x is equal to 0.2 into this here. So it's going to actually be f of 0.2, which is equal to 27 of 0.2 squared plus 32 of 0.2 plus 16 over, and then it's going to be 3 of 0.2 plus 2 squared, and then 1 minus 0.2, and then if you put all of this into a calculator, you get our value to 4 decimal places of 4.3417. So therefore the percentage error is going to be called the estimate, which is 4.39, minus the actual, which is 4.3417, over the actual, which is 4.3417, times 100. And if you put this into a calculator to two significant figures, is equal to 1.1%. So the percentage error from subbing x is equal to 0.2 into here and subbing x is equal to 0.2 into here is 1.1%. So it's very accurate. It's a very accurate estimate. So what this is actually saying is this is very accurate, and we don't need the rest of the terms, so the x to the power of 3, x to the power of 4, x to the power of 5, in order to get it extremely accurate. Just using the first 3 terms, or technically the first 2 terms, because there is no x term, gives us a very accurate answer. So for question 3 part A, we need to find the binomial expansion of 4 plus 5x to the power of a half. So as this number here is not 1, we need to factorise. So let's factorise out the 4. So it's going to become 4 of 1 plus 5 over 4x to the power of a half, and then we're going to bring the 4 out of the bracket here and put it to the power of a half. So it's the square root of 4, which is equal to 2, and then 1 plus 5 over 4x to the power of a half. And now, because this first number here is 1, we can do a binomial expansion on this bracket. So the first term is going to be 1. We only actually need to go up to the x squared term, so it's a bit less work. The next term is going to be half times x, which is the 5 over 4x, which is equal to 5 over 8x. And then the third term is going to be half minus 1 over 2 factorial of 5 over 4x squared. So we can simplify this to a half minus a half over, and then 2 factorial is just 2, and then it's going to be 25 over 16 x squared, and then this is going to be equal to minus a quarter over 2 of 25 over 16 x squared, which is going to be equal to minus 1 over 8 times 25 over 16 x squared, which is going to be equal to minus 25 over 128 x squared if you put it into a calculator. So again, we only need to go up to the x squared, so therefore this bracket here, so this whole thing is going to be, so we've still got the 2 at the front, and then it's going to be these terms added together. So 1 plus 5 over 8x minus 25 over 128 x squared, which is equal to, if we expand the brackets, 2 plus 5 over 4x minus 25 over 64 x squared. So this bracket here, the binomial expansion, is equal to this expression here. So for part B, we need to find the exact value of this bracket here when x is equal to 1 over 10 and it needs to be in the surd form. So as we need to find the exact value, it needs to be in the form of a surd. This is kind of indicating that we don't use this up here. We actually sub x is equal to 1 over 10 into this here and find the exact value that it gets out. So it's going to be 4 plus 5 of 1 over 10 to the power of a half, which is going to be equal to 4 plus a half to the power of a half, which is going to be equal to 9 over 2 to the power of a half. So this is going to be equal to the square root of 9 over 2. Remember, we can split this up into the square root of 9 over the square root of 2. So this is going to be equal to 3 over the square root of 2, but it wants it in the form k of root 2. So what we can do is you can rationalize this denominator by getting rid of the root 2 in the denominator here. You can just put this into your calculator in order to get the value for when there is not a root number in not a surd in the denominator. But the way we can just do it is do 3 over root 2 times root 2 over root 2, so we're timesing it by 1, as this here is 1 root 2 over 2, and this is equal to 3 over root 2 over root 2 times root 2, so it's going to be 2 like this. So this here, 3 over root 2, is equal to 3 root 2 over 2, so therefore this is equal to 3 over 2 root 2. So this is of the form k root 2, where k is equal to 3 over 2. And then for part C, we need to substitute x is equal to 1 over 10 into our binomial expansion here to find an approximate value for root 2. So we're going to sub x is equal to 1 over 10 into this to get 2 plus 5 over 4 of 1 over 10 minus 25 over 64 of 1 over 10 squared. And if you put this into a calculator, you get out a value. It wants it in the form p over q, like a fraction, so therefore don't put it in decimals, put it in a fraction. It's going to be 543 over 256 if you put it into your calculator. But as we talked about before with a similar question, this is not the approximate value for root 2, because we saw before that when you sub x is equal to 1 over 10 into this, you get out the value of 3 over 2 root 2. So therefore this is the approximate value of 3 over 2 root 2, 543 over 256. So therefore the approximate value of root 2 is when we divide both sides by 3 over 2. So it's going to be 543 over 256 divided by 3 over 2. And if you put this into your calculator, therefore root 2 is approximately equal, the approximate value in the form p over q is equal to 181 over 128. So root 2 is approximately equal, according to our binomial expansion, of 181 over 128.